Welcome to Why, where we ask the questions that unlock the secrets of the universe.
Okay, a little backstory first. The day was October 14th, 2017. A strange cosmic object was flying past our planet, and no one had the slightest clue. 5 days later, the interstellar object was on its way out of the solar system when Robert Werrick, an astronomer at the University of Hawaii at Manoa, spotted it with the Panoramic Survey Telescope and Rapid Response System in Hawaii. It was, from the moment of its discovery, a weird object with a weird orbit, speed and properties. The strange object was nomenclated Oumuamua, the first known interstellar object to visit the solar system. But here is the thing. It left the solar system faster than it had entered, never to return again. And here is when it becomes really interesting. While tracking Oumuamua, we expected perhaps naively that it would follow a hyperbolic orbit, as though the only force acting on it would be gravitational. What we found out, however, was that a normal perfectly hyperbolic orbit didn't quite fit what we observed. It was as though there was an additional acceleration, as though something unobserved were pushing it in addition to the influence of gravity. Shaped like an elongated cigar, by the time it was spotted, it had already zipped by our own sun, performed a slick hairpin turn, and begun hurtling off in another direction. Two things in particular fixated scientists. The first was its mysterious acceleration away from the sun, which was hard to reconcile with many ideas about what it might have been made of. The second was its peculiar shape. By some estimates, it was 10 times as long as it was wide. Over the years that followed, scientific journals and global media headlines swarmed with speculation. Was it a block of solid hydrogen? Could it have been a debris? Or was it, as the esteemed Harvard astronomer Avi Loeb suggested, an artificial construction made by an intelligent extraterrestrial civilization? Since the mysterious traveler is out of range of existing telescopes, there is only one way to find out. We go after it. A new research outlines a mission called Project Lyra to send a probe to see if Oumuamua is as extraordinary as it appears. Theories to explain the nature of Oumuamua have included a hydrogen iceberg, an alien solar sail, and fragments of a tidally disrupted planet, and so on. All explanations have one feature in common. They are extraordinary. The research recommends a mission that launches in February 2028, spends 4 years getting gravity assists from Earth twice, and then Venus and Jupiter, and finally reaching Oumuamua between 2050 to 2054. This isn't the first attempt to plot a course for Oumuamua, though most of the other attempts have resorted to using an O-berth maneuver around the sun. That tactic sees a spacecraft fall into a gravitational well and, as it's falling, use its engines to add more acceleration. Its disadvantage is that a massive shield would be required to protect a probe against the sun. Instead, Project Lyra employs an O-berth maneuver around Jupiter. The mission would much more resemble existing interplanetary missions. The drawback is that launch opportunities are very limited. The other option, of course, is to wait until another object like Oumuamua comes along and visit that one instead. After all, there could be 7 passing through our solar system each year. It could even be that most comets come from other star systems. It would not be wise to wait, according to the scientists, because the second interstellar object ever found, to Borisov in 2019, resembles minor bodies already found in the solar system. This makes Oumuamua even more of an oddity, and it is unclear what the likelihood of encountering a similar object again is. Meanwhile, Avi Loeb suggests that not only are there aliens in our galaxy, but there are actually 4 quintillion Oumuamuas speeding across our solar system. To be fair, Loeb isn't outright saying Oumuamua was an alien spacecraft per se, but he is saying we should be open to that possibility. In light of that outlook, he's basically asking what respectable scientists would never deign to do. How many possible Oumuamuas could there be in our solar system that go unnoticed? Loeb and fellow Harvard astronomer Carson Ezell looked at how many interstellar visitors we've already spotted. One can use recent traits of detection of interstellar objects and known capabilities to estimate the density of similar objects in the solar neighborhood. The astronomers wrote in the study, "Since Oumuamua, there have been 3 more interstellar objects detected by astronomers, making it 4 in 8 years. At that rate, Loeb and Ezell calculated there could be up to a staggering 40 decillion interstellar objects in the entire solar system, including areas beyond the reach of our instruments. That number is brought down to the more humble 4 quintillion figure when limiting the scope to the habitable zone near the Sun, which is potentially exciting since if some of them are aliens, they'd be easier to detect." Some of Loeb's theories are boundary pushing, but he never fails to raise some fascinating points. Even if the majority of 4 quintillion interstellar objects turn out to just be bits of space rock, which Loeb admits is likely, that still leaves quite a bit of room for some of them to be alien spacecraft. But where are they? The first thing that comes to my mind is the Kuiper Belt, a cold, dark, and distant space in the outer solar system. It's primarily made up of icy objects, dwarf planets, dust, and comets. So far, over 2,000 Kuiper Belt objects have been catalogued. Researchers believe these are only a tiny fraction of the total number of objects scientists think are out there. But one thing that fascinated NASA in the Kuiper Belt is the 15A10 R1. A quick Google search will tell you that R1 is a Kuiper Belt object, a large rock that orbits round outside the orbit of Neptune. But is it a rock? In April 2016, NASA's New Horizons spacecraft reached the Kuiper Belt. After capturing its first target, Pluto, the probe turned its sight towards a large object on a strange trajectory. Yes, we are talking about 15A10 R1, named after the Celtic god of death, war, and the otherworld. Now, why is it so special, you ask? Well, most of the objects in the Kuiper Belt are made of rock and ice. But R1 doesn't move like any of catalogued objects in the belt. This has made scientists question if it is made of something completely different, something much stronger, because it's rotating so fast that centrifugal force should have torn it apart. How could something spin so fast and stay intact? Scientists believe that the fast spin is creating artificial gravity, and gravity would be the most vital thing needed for long interstellar travel. You cannot have astronauts floating around the spacecraft while traversing hundreds of light years. This probed the New Horizon to take a closer look at the object. And here is when things turn strange. As the probe tried to get a closer look, suddenly, all of its sensors went dead, transmissions cut off. It was as if someone was monitoring our presence. Someone or something that did not want us to know about them. But just before losing contact, NASA observed that R1 was spinning like a large spaceship would. Now, you can say that it might have been a technical glitch. But here is when things get crazier. Only when New Horizon moved away from R1, it suddenly came back to life as if nothing had ever happened in the first place. Now I would leave it to you to assume what it was. But if it's an intelligent alien civilization, it makes complete sense to stay far away from Earth and silently observe us from the cold and dark space in the Kuiper Belt. And whenever the need arises for a closer inspection, hop onto a spacecraft and camouflage it so that it appears as a mere space rock to the beings of the planet. In addition, Loeb also suggested in the past that Oumuamua could be a piece of alien space junk, a defunct sailcraft that has accidentally found its way to us. Or it may be an active reconnaissance craft sent here to check out our solar system, he had written in the study. There are reasons to favor the latter explanation, Loeb said. For starters, Oumuamua's very discovery was something of an anomaly. Our own solar system doesn't shed so many Oumuamua-like objects. In addition, Oumuamua's motion is roughly coincident with the average motion of material in our patch of the Milky Way galaxy, a kinematic space known as the local standard of rest. Indeed, that's why the object's system of origin has been so hard to pin down. If I created an instrument whose identity I would like to hide, I would put it at the local standard of rest, Loeb said. Astronomers have used the Green Bank Telescope in West Virginia and the Allen Telescope Array in Northern California to listen for any possible pings coming from Oumuamua. To date, the object has remained silent. What do you guys think? Should we go after Oumuamua or wait until another one shows up at our doorstep? Drop in your comments to let us know, because together, we will explore.